To build off what we said in the last video, I wanted to have us take a look at the following example. I would like to graph the parametric curve. X is equal to, whoops, wrote an X there initially, t squared minus 6t plus 1, and y is equal to, whoops, initially wrote a y there, t minus 2 as t goes from 1 to 5. So what we're going to do is essentially akin to graphing by plotting points. Now, normally for graphing by plotting points, we create a spot for x and we create a spot for y. Here we're going to create a spot for t, as well as x and y in a table. Now, because t varies from 1 to 5, what we're going to do is use some integer values in between 1 and 5. And then we'll start plugging these into the two given functions. So we'll interpret this as x of t is equal to t squared minus 6t plus 1, and y of t is equal to t minus 2. So I'm going to take care of the y values first because those look like they'll be relatively straightforward. So for t equals 1, we would have 1 minus 2. We'd get a y value of negative 1. For t equals 2, we would get y is equal to 2 minus 2, which simplifies to 0. For t equals 3, we'll get 3 minus 2, which will be 1, and you're probably starting to see a pattern at this point, so we'll just go ahead and fill in the rest of these. Now x is probably going to be a little bit more complicated. Let's start with t equals 1. We'll get 1 squared minus 6 times 1 plus 1. That's 1 minus 6 plus 1, which I believe simplifies to be negative 4. For t equals 2, we're going to have 2 squared minus 6 times 2 plus 1. That's 4 minus 12, which is negative 8, plus 1, which will be negative 7. At t equals 3, this will be 3 squared minus 6 times 3 plus 1. 9 minus 18 is negative 9, plus 1 is negative 8. For t equals 4, 4 squared minus 6 times 4 plus 1. 16 minus 24, that's negative 8, plus 1 is negative 7. And finally, for t equals 5, we'll get 5 squared minus 6 times 5 plus 1. That's 25, minus 30, that's negative 5, plus 1, we'll get negative 4. Now hopefully this sort of pattern here with the x values is sort of expected, given that we had a quadratic. We see that this thing is symmetric about t equals 3. Now, given that the y values, some are negative, some are positive, but all of the x values are negative, I'm going to draw this with a special emphasis on quadrants 2 and 3. So 1, 2, 3, 4, 5, 6, 7, 8. Negative 8, negative 7, and negative 4. For y, we'll see a negative 1, we'll see a positive 1, positive 2, and a positive 3. Now, as I'm plotting these points, I'm going to indicate what values of t we have associated with them as well, and that will allow us to create an orientation for the curve. An orientation for the curve, orientation, is going to be the direction of increasing t. The direction of increasing t. So as t is getting larger, this will allow us to point the curve in a given direction. So for t equals 1, we had negative 4, negative 1. That would be right here, and that's t equals 1. For t equals 2, we have negative 7, 0. That would be right here, associated with t equals 2. For t equals 3, we would have negative 8, comma 1. That'll put us right here. That's t equals 3. For t equals 4, we have negative 7, 2. Negative 7 and 2 will put us right here, t equals 4. And then for t equals 5, we have negative 4, 3, which would put us right up here, t equals 5. Now with that in mind, because t has a definitive stop at these 2 points, we're not going to put an arrow at the edge of this curve. We're simply going to stop at those 2 points. Based on what I'm seeing here, it's looking like we're going to have a parabolic shape passing through these 5 points. Now, for the orientation of the curve, we need to indicate the direction of increasing t. As t gets bigger, y gets bigger as well. So I want to just make a little arrow on the curve indicating the direction in which we are traveling as t increases. You could just do one of them, you could do two of them, You can do multiple ones just to make sure that we know as t increases, this is the direction in which it's going. Now, another way that we could determine what's going on with this parametric curve would be to eliminate the parameter. Now, we'll discuss eliminating the parameter in the next video, and then we'll revisit this example.